Hello everyone, my name is Jim Clark, and the topic for today will be tools. And more specifically, this talk will be about how we can integrate tools into our GenAI workflows. So the top level picture starts on the left with the LLM. And typically an LLM is going to respond with text. But what we're going to focus on today is when the LLM responds with a tool call or a request for the system to call a tool on its behalf. So in a sense, this is a way for the LLM to expand its capabilities with the output from tools. So this tool process that we're running here actually looks a lot like a cloud native compute process. Shares a lot of the same characteristics. So what do we want from an engine that can run tools for us? Well, we want a safe runtime. So we want isolation from the compute. We want to make sure that we can pull tools from trusted locations. We want to run safe tools. So we want to pull them from places like Docker Hub or other Docker registries. And wherever these assistants happen to be running, wherever an LLM happens to be running and generating these tool calls, we want to make sure that we can distribute those tools safely to that runtime. So it has a lot of these characteristics that we are familiar with Docker runtimes. So we're looking at how we can integrate tool calling on top of Docker. So all the examples that we give you today in terms of tool calling, they'll all be tools that are running in your local Docker engine. So we're going to go through a few examples just to make sure that everyone understands what we mean by an LLM being able to call a tool. And so we'll start with something really simple, like just a LLM says, hey, can you run curl for me to get some data? Then we'll move on to sort of a more characteristic use case for tools right now, where there's an external API that has data that you need to bring into a conversation, fetching up-to-date information. Then we'll move on to something probably much more interesting, which is that LLMs can be planning agents. They can build out workflows where some of the tasks in the workflow are implemented using tools. So here's the simplest conversation that involves a tool. So let's start at the top of this, where maybe a user simply says, run the curl command to fetch my gists. Now, an LLM can't do that, but it could instead generate a response. And here we say that the LLM's role here is as an assistant, could generate a response with a JSON payload that describes how to run the tool that it needs to run. For example, in this case, how to run curl. So Docker could pick that up, run curl on behalf of the LLM, and return, and here we call this role tool, but return the content from this so that then the assistant can continue the conversation. So I think it's a good idea to think about this as a thread of a conversation where the assistant asks the system to run a tool on its behalf. The output of the tool comes back and forms part of the conversation, and then the assistant continues with having the benefit of this tool output. So let's take a look at how that looks in practice. Okay, so let's start with a completely blank canvas here and author a prompt. In our prompt workbench, where we just use Markdown, we allow ourselves to define the role of the prompt just using h1 tags. And what I want for this prompt is, I just want to say run the curl command to fetch gists for user Slim Slender Slacks, which is me, from GitHub. Okay, so my prompt here is I'm asking the LLM to run curl, fetch these gists for my user from GitHub. I am not giving it any tools. So this is just a raw execution of a prompt with no tools. So let's run that. and we're going to get a response from the LLM, and it is saying, yep, you can do that. Just run this curl command, which is pretty good. That's a good response. But now let me redo this. But this time I'm going to define some tools. So one of the tools that we ship by default is curl. And what I mean by ship that is that we are the curl image, the curl Docker image has enough metadata in it that I can just pass this tool directly to the prompt engine, and the LLM will know when it needs to call curl. I don't have to have curl installed on my machine here because the curl command is just running out of Docker. So let's run that prompt again. And the first thing that we're going to notice here is the assistant is going to generate a response, which is a function call. So instead of just saying how to run curl, it's going to generate a function call to say, hey, can you run curl for me with these arguments? And this time the response has gotten my gists back from GitHub, and this is the LLM formatting my gists for me in a way that I can sort of quickly navigate them. So instead of just saying how to run curl, here it can actually go in and really run curl. Okay, let's look at the next example where we use a tool to call an API. So the actual conversation flow here is very similar to the last one. We start with a message from the role user where the prompt is, can you recommend a good base image tag for Node? And the LM can then follow up with a JSON payload to ask our engine to run a tool to call a GraphQL API and get a better recommendation. And then the assistant can respond with a combination of what it already knows and some information that's been pulled back from this GraphQL API. And hopefully this improves the ability of the assistant to make a good recommendation here. So what does this look like? So here's the prompt. It's a very simple prompt again. Can you recommend a tag for the Docker Node repository? And when we look up here, we've given it no tools. So the first thing we're going to do here is just run this prompt without any tools. And it comes back with a recommendation here. And we might think that this is not a great recommendation. So now we will go into the tool definition and give it another tool. And here it's a tool we've just written. This is a Docker image, Docker Scout tag recommendation latest. So this is a Docker image which defines the API function and has some metadata to let the LLM understand how to call it. So let's call this again now. And this time, as same as last time, we should expect that the assistant is actually going to generate a function call, and it does. And the tool returns the response 22-slim. And now the recommendation from the LLM is I recommend 22-slim tag for the Docker Node repository. And this is some information that it managed to get from this GraphQL API. In the third example, we're going to look at workflow. So on the right side, there are 3 tools that we need to integrate. We need to let the LLM plan activity over these 3 things. And the prompt that we're going to do here is, I want you to create a Docker file for this particular project. And this project is the key here because we need the LLM to be able to run a tool to analyze this project and see what's the tech stack here, what kind of content is here, how do I select the right best practices to author more effectively, which I want to run a tool like I did last time to figure out what kind of content I should use to base this new Docker image that I'm building. And finally, instead of just writing out the Docker file, we're going to give it a tool to write the file back into the project. And so we're going to give it this write files tool. So overall, the overall thread of this conversation is a little more complicated because it has to plan over some tools. But let's see what this looks like. So first off, in this one, I'm going to give it a system prompt to tell it that it's an assistant that specializes in authoring Docker files. But the important thing is this user prompt. And so the framing for how to think about this is to tell the LLM, first, you should analyze the project and determine what kind of content is there and pull all that information into the conversation. Second, get best practices on, once you know what the content is, use that to figure out what best practices are applicable. Then, once the analysis is complete, create a Docker file for that project, and in this case, hopefully it will write the Docker file back to disk. So what are the tools that we gave it here? The Analyze Project tool, obviously, we gave it a function so that it could write back to the file system. This is the same function that we used in the last demo. And then this is a new one. This function takes as input the information that we have about the tech stack, and it goes out and fetches best practices from Docker content from docs.docker.com that we think will be relevant for authoring whatever project it finds. So my prompt here is pointed at a project that I have locally on disk, and let me get this started. So the LLM is now doing an analyze project and trying to figure out what this is. It sees that it's an NPM project. And now this is interesting because it uses that data to then go out, and what you see here coming back is a set of best practices about writing Docker files for NPM projects. This is things like use 3 different stages, use cache mounts. That's what you see down here. And if you find that it has an NPM start, then use that inside of the Docker file. So the next thing it's going to do is it realizes that it needs another node base image, as we saw last time, and we want to use 22-slim here. And then it starts to write out the Docker file. And you see this inside of a function definition because it's planning on writing this content out to disk. And if it does this, in the end, it writes one file to Docker file and says, look, I've created a Docker file for your project using these best practices. Here are the 3 stages that I've built. It's all set now. And so let's take a look at what it wrote. And this is what it decided to write. So it's using 3 stages. Some of these directives that you see here are coming out from our best practices. And it's a pretty decent job. This Docker file here for the project that I pointed it at is a better Docker file than I would have gotten if I had just asked the LLM to write me a Docker file for Node. I've gone through 3 examples here. In each case, an assistant was given a new capability by us adding a containerized tool to the LLM's arsenal. This is an example of us just using Docker engines to host tools. We are working now with local LLMs to try to produce a local assistant form factor. Some of the work that we're doing right now is looking at a lot of different developer-facing tools like linters and having LLMs that can kind of pull in the right linter to help you understand and fix code. Editor integrations, the prompt workbench that you saw today, I was running out of a NeoVim extension, but the NeoVim plugin, but we also have a VS Code plugin. All of this we're doing in open source project called Labs AI Tools for Dev. Feel free to follow along. There's a QR code on the side there. And interesting story about this QR code. when I went to generate a QR code, I sort of obviously asked myself, hey, I wonder if there's a tool to generate QR codes, and there is one called QR encode. So I put that in a Docker image, and actually used Llama 3.1 for the function calling interface, just to demonstrate that we can do this with local LLMs, and then just asked it to generate a code for this particular URL. And this is a pattern that I find has been really kind of useful for trying out different tools. Like if the LLM at first generates a function call which doesn't work, read the man page and just try again. And maybe it will learn something from having read the man page. But yeah, that generates a nice QR code. And so thank you very much for your attention, and please reach out if you have any questions, or if you're interested in the work. Thanks.